What's a Poisson process? If you see this way, suppose this is time 0, this is time 1, 2, 3, 4, 5, that way. You can say this is first week, second week, third week, or first month, second month, whatever. So we are talking about the number of claims. I can write here NT. Again, the notations are interchangeable. We write sometimes XT and sometimes XT. So NT, you will see somewhere, and NT. In most of the cases, when it's discrete, we write this way, and when it's continuous, we write this way. So NT is a stochastic process here. NT, I can write the number of claims up to time t. Any kind of claims. We are talking about general insurance claims here. Motor insurance claims till time t. That follows a Poisson process. When we say Poisson process, from 0, next day it's 5, we say parameter. So let me write with parameter lambda, with follows, I should write, follows a Poisson process with rate, here in this example, rate 5 per day, 5 per week, 5 per month, whatever you want you can write. I can write suppose day. In one day we receive 5 claims. We are part of general insurance company and we receive 5 claims in one day. So after one day you will have 5 claims, after another day you will have 10 claims, after another day you will have 15 claims. That way it will continue. It will never decrease. It's a counting process. Poisson process means, first of all, the prerequisite is it must be a counting process. Counting process will never come down. In a class, suppose someone is giving a class and the teacher is waiting, students will come from time to time. If the teacher counts the number of students present, it will always increase. If someone will go out of the class, we will not consider them. That's a separate thing, separate issue. Suppose students are coming, then the number of students they will enter, that will never increase. That will remain constant or that will increase. That will always be increasing function. So from here, we always go here, from here to here, or from here to here. These are only 2 alternatives. If you see, after some time, suppose 1 hour, 40 students are here. This is 10 am. At 11 am, if you see, either you will have 50 or 40, or it could be anything, but it will not decrease. It will remain here or here or here or here or here. So the increases are there, 10 increases in each hour. Again, we are talking about fixed lambda here. Lambda might be different. Okay, constant rate. If you want, we can write constant rate also here, but normally we consider constant rate only. So 5 per day here. This is a counting process. This will always increase, or this will remain constant, but this will never decrease. If you ask me, in this diagram, I have always written here 0 to 5, 5 to 10, not 5 to 5. Okay, then I will go to this one. We are talking about very small time interval. I'll go to the definition, there it will come, but remember Per day it's 5. Ideally I am saying, because now at time 0, suppose today is 1 January 2021, we are talking about tomorrow, we are talking about day after tomorrow. These are the values 5, 10, 15, it should touch, but how it will touch 5 and 10, that's what we'll discuss here in Poisson process. And you see, this is a Markov process and this is a stochastic process, but it will never come down. So Poisson process is a stochastic process, Poisson process is a Markov process is a stochastic process, but not all Markov process are Poisson process, because it will never decrease. A general stochastic process can decrease as well. Here it's increasing, but it will not increase always. That's what will come across here. If you see this one, if you consider a small time interval, I am not talking about the full day, 24 hours. We are talking about a very small time interval, t to t plus h. Suppose you consider second day and third day. In between there is a small time you take. Suppose 10 am to 10 am and 1 minute, or maybe 1 second. Within that 1 second, if company received some claims between 10 to 15, I can change this 12. Next time either it will be 12 or 13. I have written 7 wrongly here, so you can write from 12. I can erase all. Oh, this is something I can't erase. Okay, no problem. So if it's 12, the next time it will be either 12 or 13. That's what we are saying. This is the definition of a Poisson process. Poisson process will take only one increment at a time in a small time interval. We are not talking about 1 year. That constant, the rate will come, rate 5 per day, that's fine. But within that also, the increment in a very small time should be either 0 or 1. That is the definition of Poisson process. 12 to 12 or 12 to 13, that is the definition. M0 is 0, that stands. At time 0, 0 number of claims. After 1 day, 5 claims. But how 5 claims will come, that is important. So the 5 claims should come this way. One claim between 10 to 11, another claim between 11 to 12, another claim between 12 to 1, then one between 1 to 2, then one between 5 to 6. This way it's fine. But all the 5 claims within 1 second, this is not fine. Suppose a doctor is here, this is clinic, and doctor is giving service to patients. Doctor is sitting here, and when patients will go, normally if they go randomly in a very small time interval, okay, these are the chairs here, in a very small time interval, either small time, when I say, it could be half a second, either one patient will enter or no patient will enter. In India it's a different thing. Sometimes 5 people enter, but patient is 1, all 4 they support. So if 5 are entering, will not worry about the other 4 which are not patients. Even if you say no, many patients are coming, that's not a Poisson process in that case. Remember, in a very small time interval, doctor should treat only one patient or no patient. It's like, now I am waiting to receive a call. My mobile is there with me. I am giving you a class. So in the next 10 seconds, either I will receive one call or I will receive no call. If that will happen, and I think that's true, then the calls I receive, that follows a Poisson process. Poisson process definition is, you should get 1 or 0, that's all. More than 1 is impossible. So if you consider very small time interval, you are not talking 1 day. 1 day the rate is 5 anyway, from 10 to 15 it will move. From 0 to 5 it will move. We are talking about very small time interval. So if you consider 10 to 11 or 12 to 1 hour I have taken, okay. So in discrete time intervals claims will be there, so that there will be no overlapping of claims. And in total there are so many small time intervals, like if you divide in seconds, there are so many seconds. Out of those all seconds, 1 1 1 1 1, and they contribute to 5. So from 0 it will be 5 next day. So it's not that company will not get many claims, company will get many claims, but in discrete time intervals, mathematically we write this way. If you consider a very small time interval, suppose this is t, and the interval next to t plus h, where h is very small, then if you check, this is the definition. The definition is, if you consider t very small time interval h and the next neighboring point t plus h, if you see the number of claims nt or nt, whatever we write, nt the number of claims till time t, and t plus h is the number of claims till time and t plus h. So if this is 12, either this will be 12 or 13. The jump will be in units, only one more in a very small time. Suppose this is a town, and there are intersections. These are the intersections, roads. Now if you see accident happening, okay, the accidents happen at intersections. If you see the number of accidents, that will also follow a Poisson process. Suppose now it's 10, and I'm recording the accidents in a particular town. So what will happen is, between 10 to 10.1, I get a call from somewhere saying that there is an accident. I will arrange something, but it's not that within that 1 second there will be accident here, there will be accident here, there will be accident here. I mean, it's very rare. That's why there is a concept of serial bomb blast. So when we talk about serial bomb blast somewhere, we see that there is a conspiracy theory. Maybe someone is operating and he instructed to blast all the bombs at the same time. I mean, within 1 second you see one by one. Also in different festivals we use crackers one after one. Otherwise, because the events are random, how randomly one driver is going here, one driver is going here also, and at the same time 10 am or 10 to half second you can end. Within that time only, at the same time 2 will happen. Because there are so many instances, even if you have 50 accidents, I don't think there are 50 accidents happening in a day. Even if they are happening in a day in a particular town, 50 accidents, yeah, in one day that might be possible, but then in different times. Suppose one accident happens at 10, another 10.2, another 11, 12. I mean, we have 24 hours, okay, within that time 50 accidents is possible, but not at the same instant, or maybe very small time interval. It's not possible. Even if it's possible, then that will not be a Poisson process. So if you see here, not 1 day or 1 week, whatever, I'm not talking about that. If you consider very small interval, time interval, either there will be an accident or there will be no accident. So the number of claims already we received X. So after very small time it will not increase drastically. If at all it increases, it will increase by 1. So by definition, if you write, if you count this one and this one, if you subtract, this will be 0 or this will be 1. 2, 3, 4 chances are 0. And we have written order of H, that is a very small amount. And if you add these two probabilities, it will be 1. Lambda t, 1 minus lambda t. If you add the probability that nt plus h, that is the total number of accidents, total number of claims till time t plus h, NT counts the cumulative number of claims till time t. The difference is 0. That means they are the same. This case. The other one is there is a difference of 1 only. X plus 1 minus x, that is 1. So either 0 or 1. If you sum up these two probabilities, it will be 1. Lambda t will be cancelled. There is a proof also. I don't think that is important here. We will not worry about that. So we are talking about rate here. There is no definition of Poisson process, only 5 per day, 10, 15, cumulative till second day, that is 10, then in 3 days 15, in 4 days 20. So with a constant rate it's increasing. That rate is lambda here. We write this way: NT follows NT or XT or NT follows, in this case, Poisson distribution, Poisson with lambda t, 5t. Lambda is 5 here, and interchangeably you can write this way or this way, it doesn't matter. So NT is a Poisson process. If it's a Poisson process, you have to write this way. So from a random variable Poisson distribution, we came to Poisson process. Again, when we write all, that's a process. These are the different times. But if you consider a particular time t, NT, that's a random variable. This is a random variable. The totality is the process. If you pick up one time and you find this one NT, that will be a random process, or random variable. The totality is random process. Now what else? Yeah, this is what we write: 5 per day. This is Poisson process, and the definition is this: either 0 or 1 we can write. I am not going through the proof. Even I may have other videos where I proved also. I don't think that's important because we have so many other chapters here. Now there is a question: the number of death amongst retired members of a pension scheme occurs at a rate of 3 per calendar year. The question is, calculate the probability of 5 deaths in January to March inclusive. Then another one similar to that. So here the first thing is you need to write the symbols properly. If I write N here, NT follows Poisson. This is a random variable. NT follows Poisson. Lambda t, lambda is 3 here. Okay, so I have to write t here, 3t here. NT follows Poisson 3t, and then we need to find probability that N3 is equal to 5. So when you find probability N3 is equal to 5, because the rate is 3 per calendar year, lambda is 3 here, ND, okay, that's fine. I should have written another line, not a problem. Let me write this way: lambda is 3 here, lambda t. Now in part 1 you have to find the probability that N3 is equal to 5. So how to find probability N3 is equal to 5? T lambda. Let me write lambda T only. Because I have written NT here, then we'll replace it by this. NT follows Poisson lambda is here, right? 3T. Then the question is 5 days from January to March, and you have to see the rate 3 per calendar month. So this is 1 month, this is another month, this is another month, so this way. And when we talk about N3, that means up to 3, January to March. Suppose January, if you say 0, February 1, this is January, this is February, this is March. January, March, okay, 1 January to 1 February, 1 February inclusive, okay. So this is 1 month, this is 2 months, this is 3 months. March, this is March, and you can see, okay, end of March, 31st March, this is 1st March, that way. So in three time units, cumulative you have to find, okay. So up to this the notation is there, up to this is N1, up to this it's N2, then up to 3 this is N3. What is the probability that N3 is equal to 5? We know the definition of, we know the distribution of NT, we'll use that because this is a random variable. So this is also a random variable, all are random. N3 is a random variable, N1 is a random variable. N3 follows Poisson (9) here, okay. Then what is the probability that N3 is equal to 3? So again, when I talk about a random variable, this is the average one. Average is lambda. The lambda means the parameter is 9 here, but it could be anything, 5 or 6 or whatever. So you can find this way also, x is equal to 5, where x follows Poisson 9. What will happen is this will be a random variable problem, but this notation is important. We have some problems, I'll send you, where we always use this notation because we are doing stochastic process. Though this becomes a random variable, if you take point by point, that becomes a random variable. The whole totality is called a Poisson process, but individually at every time you have a random variable. Similarly, the second one you can do 12 days in June to October. Here also, if you want, you can write this way. Probability N3 is equal to 5 I have written. You could have written N3 minus N0 is equal to 5. Though, will not worry, the total time period is 3 here. We are talking about homogeneous. In the second case, if you see here, June, July, August, September, October, you can write N5, or maybe you can, if you are starting this way, January, February, March, April, 1st of April, May, June, if you count that way, suppose you write 11 here, you have to write 6 here, the total is 5. Then you have to find the probability. So this is also a random variable. Our theorem is like this: NT follows Poisson lambda T. Not only that, NT plus S minus NS. If you see here, the difference is again T. It doesn't, the first one, in the first one, the time is from 0 to T. If you are not writing anything, it's 0 to T. Even you can write this one as nt minus n0. That follows Poisson lambda t. From 0 to t, this is t. From s to t plus s also, this is t. So instead of the times, we see the interval. That's important. It doesn't matter whether it's 1 to 4 or it's 11 to 14, because it's homogeneous. And n0 is 0. That's why even if you don't write this, it doesn't matter. See, Poisson process starts with 0. That's another property I didn't write maybe. So these are there. It will always start with 0. These are any two times. You see, I must have written it starts with 0 always. Poisson process n0 is always 0. It starts with 0 always. So you can freely write nt follows Poisson lambda t. Yeah, we'll go to Kolmogorov. There is another question here. The number of claims arriving an insurance company follows a Poisson process with an average of 5 claims per day. That's lambda. What is the probability that the company will receive 4 claims tomorrow? We're talking about one day. So one day means directly you can write probability that n1, that one day, if today it starts from today, that's n1, that's fine. If we started 5 days before, maybe it's n6 and minus n5 they're asking. If the process starts from today, okay, so tomorrow means directly I can write 0 to 1, that is 1. If the process started 5 days before, by tomorrow it will be 6th day, up to today it's 5 days. So in one day, 4 claims tomorrow. Tomorrow means only one day. So it could be this or this. However, it doesn't matter. We'll write this way only. Even the distributions are also same. So probability that this is equal to 4. So to find this one, even you can write this as probability x is equal to 4. You need to know the distribution of x. Nt follows Poisson lambda t. Lambda t. So x follows here Poisson t. Lambda is given 5. So 5 here. We know the distribution of x. Then this is a random variable. So using random variable concept, you can solve it. E power minus lambda, lambda power x upon x factorial. You can find this. Then 40 claims in the next week with an average of 5 claims per day. So we are counting day. So 7. 40 claims in next week. Next week means you have to find probability that in 7 days you have 40 claims. So to find this, you have to write, remember there are so many random variables here. We are interested in this random variable n7. Nt is a random variable for all t. n7 follows Poisson lambda t. Okay, t is 7 lambda. So n7 follows Poisson 5 given 35. So using this is a random variable. This is equal to 40. E power minus lambda. Lambda is 35 now. Power x divided by x factorial. This way we can find.